So this is problem 226 out of the textbook. Basically for the question, it's determine the magnitude and direction theta of FA so that the resultant force is directed along the positive x-axis and has a magnitude of 1250 newtons. So basically that means, and I wrote it under the given, that the resultant force equals 1250 I newtons because it's along that x-axis. So because it's the resultant force, we know that FA plus FB is going to equal that resultant force. So one way to do this would be just to write these out in Cartesian form. So FA is going to equal that magnitude of FA, and for the I direction we want along that x-axis, so that would be sine of theta, and that's in the positive x direction. And then for the y direction, or the j component, it'll be plus FA because this is also up, and then cosine of theta j because cosine is the adjacent one, so that would be along that y-axis. So that for both of those we have two unknowns basically in that calculation. For FB, we know more about that one. FB equals 800 newtons, and for that FB we know more about it. It's the 800 newtons times, for the I, cosine would be that x component, so cosine of 30 degrees I, and that would be minus, because the j is in the negative direction, 800 newtons sine of 30 degrees j. And then the resultant force, which we already wrote, is that 1250 I newtons. And so because we know this relationship here, that FA plus FB equals FR, we can basically break down each of those components. So for the FA plus FB, if we just take the I component, so I, then we can say that FA sine of theta plus 800 newtons cosine of 30 degrees equals 1250 newtons. So we have a relationship there. We have two unknowns in one equation. Fortunately, we can also do a second equation for the j direction. But I'm going to go ahead and make this one a little bit simpler. So I'm just taking this component and moving it over to the right side. So we get FA sine of theta equals 557.2 newtons. So we have one equation with two unknowns, so we need another equation. So now we're just going to do the j component. And with that we have FA cosine of theta, so that's that j component. And then this one, minus 800 newtons sine of 30 degrees, and that equals basically 0. So this one we also have two unknowns, and this one we have FA cosine of theta equals that 800 times sine of 30, and so that would be 400 newtons. So there are a couple of different ways that we can do this, but we basically just need to solve these two equations with two unknowns. Alright, so I just pulled both of those equations through. So we have, basically, let's take the second equation. So we have two equations. So this is equation 1 and this one's equation 2. What we can say is that if we take equation 2, FA equals 400 newtons over cosine of theta. If we plug that into the first equation, we would get FA is that 400 newtons over cosine of theta, and then times the sine of theta, and that equals 557.2. So sine over cosine is tangent of theta, so we'll just make that into tangent of theta. That equals 557.2 divided by 400, and both of those are newtons. So I'm going to do that, and then we get theta equals 54.3 degrees. So they wanted us to know, they wanted theta and FA. So now we have theta, so now we can plug that back into that original, into that equation here. And so FA equals 400 newtons divided by that cosine of that theta, which is 54.3 degrees. So that's going to give us, let's see, that gives us 686 newtons is FA. And that's what they wanted. They wanted the magnitude of FA and the theta. So those are two unknowns. That's it.